Hello students, we are solving the Volterra integral equation of second kind using the modified Adomian decomposition method. Previously we did Volterra and Fredholm both by using simple Adomian decomposition method. Right now we have moved on to the modified Adomian decomposition method. There is just slight difference between the modified and Adomian by just a choice of function. So that will be explained during the example. This is your Volterra equation because the lower limit is constant and the upper limit is variable, and it's of second kind because the unknown function u is appearing under the integral sign and also outside the integral sign. If they ask you to solve the Volterra integral equation of first kind by using this method, then you can not directly apply it. First you have to convert the first kind into the second kind, so that there are two unknown functions here, and then you can apply this method. Now in Adomian decomposition method, we took this function as just first function f of x, and you took it equals to u naught of x. But in modify it, you are going to split it into the two functions, that is f naught plus f1, the combination of two functions. So let's start this modified Adomian decomposition method. First of all, we replace u of x as sum from n is equals to 0 is equals to infinity, then u naught of un of x. Now let's replace it here. You will get here summation n is equals to 0 to infinity u naught un of x equal sine of x plus e minus e cosine of x minus integration from 0 to x e cosine of t summation n is equals to 0 to infinity un of t dt. Now we are going to expand this series un of x and un of t. When we expand this series, we will get here u naught plus u1 plus u2 and so on equal. I am taking sine of x as your f naught and taking the rest of the terms as f1. So I can write it as e minus e cosine of x. Now let's expand this one. If I expand this, let's write it down here. 0 to x e cosine of t. Now if I expand this, I will get u naught plus u1 plus u2 and up to so on dt. Now let's expand this integral to every term. I will get here sine of x plus e minus e cosine of x minus integration 0 to x e cosine of t u naught dt. Then again minus 0 to x e cosine of t u1 dt and up to so on. Now I can compare my left hand side with the right hand side. So first term will be equals to the first term, second term will be equals to your this second term, and third term will be equals to this third term and up to so on. So let's write them together. If I will write them, I will get here u naught of x equal sine of x, and u1 is going to be equal this second term, that is e minus e cosine of x minus integration from 0 to x e cosine of t u naught of t dt. Now let's plug in this value here because this is u naught. So we'll get e minus e cos of x minus integration from 0 to x e cos of t. Now u naught of t is going to be sine of t dt. Now let's integrate it. You can use here integration by substitution. Let's take u equal cosine of t. So du will be equals to negative sine of t dt. So we'll get here after integration, I'm just applying the final integration answer here. So e minus e cosine of x plus e cosine of t, and limits of integration are from 0 to x. After applying the limits of integration, we'll get e minus e cosine of x plus e cosine of x minus e. So that is 0. Now let's take the third term, u2 of x. And u2 of x is negative integration from 0 to x e cosine of t u1 of t and dt. Now let's use this value of u1. So if you will put the 0 here, everything will goes to 0. And similarly, if you will find the u3 of x, you will again get the 0 and up to so on. Now we got all the values of the series, so you can plug in here to find this unknown function u. So let's plug in the values. So u of x is u0 of x plus u1 of x plus u2 of x and up to so on. So let's use these values here. u0 was sine of x plus 0 and up to so on. So your solution is sine of x. Now we can check whether the solution is the exact solution or not. To check it, you can use the value of this u here in your question on the left side and on the right side as well. If both the sides are equal, it means you have this as your exact solution. So let's check it. Let's use it in place of u. So you will get sine of x equal sine of x plus e minus e cosine of x minus integration from 0 to x e to the cosine of t and sine of t dt. Again, you can use here the integration by substitution that we used earlier as well. So you will get here the left hand side equals to right hand side. So u of x equals to sine of x is exact solution here. I hope you understand this. Now in next time we will do the modified Adomian decomposition method for the Fredholm integral equation.